Hello friends, welcome to engineering tutorial. So we'll continue our discussion on thermodynamics. So previously we have discussed some basic concepts related to introductory concepts related to heat, temperature, thermometry and thermometric scales, and then we discussed in a very quick way the basic concepts related to gas laws. And I said that in our future upcoming discussions there will be reference to gas laws in either a direct or indirect manner. So in this video we are going to discuss about the concept of absolute zero temperature and why it is important. See, we have discussed various scales, first Celsius scale, Fahrenheit scale, Romer scale, Kelvin scale, all that. So each scale has its own lower fixed point, that is the ice point, which is generally taken, and then the steam point, the boiling point, which is the upper fixed point. And we also discussed the interconversion between the scales. But how can we determine the absolute minimum temperature, zero temperature, which we are calling in this video? So for that, we have to first understand the relationship between volume and temperature of a gas at constant pressure. So that is given by Charles' law, which we have studied in the previous video. So according to Charles' law, if pressure remains constant, then the volume of a given mass of a gas, it increases or decreases by 1 by 273.15 of its volume at 0 degree Celsius for each 1 degree Celsius rise or fall of temperature. So here you have to understand the significance of 273.15. So if you understand 0 degrees Celsius, that is equal to 273.15 Kelvin. Okay, this is the relationship between Kelvin and Celsius. So here if we substitute 0 degree Celsius, that will get 273.15 Kelvin. So if you have to convert Celsius to Kelvin, simply add 273.15 with the Celsius temperature. You will get the temperature in Kelvin. And I also said that in most of our discussions we'll mostly be dealing with Kelvin and Celsius, these two temperature scales. So again, coming back to Charles' law, the pressure when it is kept constant, the volume is related with temperature by this. It either increases or decreases by 1 by 273.15 of its volume at 0 degree Celsius. Let its volume at 0 degree Celsius be V0. So it will always increase or decrease by a margin V0 by 273.15. Okay, and it is given by this mathematical relationship, where the volume of a gas at a particular temperature in degree Celsius is given by this. Vt is equal to V0, which is the volume at 0 degree Celsius, plus V0 by 273.15 multiplied with the temperature small t, which is in degrees Celsius. This is the relationship, and V0 is taken common, and we get 1 plus small t by 273.15, then 273.15 plus t by 273.15. So here this is nothing but the whole temperature expressed in Kelvin, because when we add 273.15 with Celsius, we get the temperature in Kelvin. So this is the temperature in Kelvin, and this is 273.15, which is 0 degrees Celsius. This is in Kelvin, 273.15 Kelvin. So volume is directly proportional to temperature. This is Charles' law. Now here, if we take a temperature below 0 degrees Celsius. Okay, as per this relationship, okay, if we take a temperature below 0 degrees Celsius, okay, minus T, let's say, then the volume at that temperature will be given by this V0 into 1 minus T by 273.15. So that volume at a negative temperature will be lesser than the volume at 0 degrees Celsius, which is the reference which we have taken. So here, when the temperature is continuously decreased, it is gradually decreased, it will also result in a decrease in the volume of the gas. Okay, so we can show this through a curve like this. Okay, this pressure is kept constant and we show a curve which gradually decreases with decreasing temperature below 0 degrees Celsius. So if we extrapolate this curve will meet at a point minus 273, or more precisely minus 273.15 Kelvin. Okay, degree Celsius. Okay, minus 273.15 degrees Celsius. Okay, always remember this top temperature, this is in Celsius. Here we have taken the top temperatures in Celsius and the bottom ones in Kelvin. So this is 0 Kelvin minus 273.15 degrees Celsius is equal to 0 Kelvin. Okay, so this is the Celsius temperature which we have taken in the x-axis, the top one, and just below we have taken that in Kelvin. We know 0 degrees Celsius is 273.15 Kelvin. Okay, so this is like that. We have the actual curve, it stops here, but if we extrapolate, because negative temperature of this much, it is impossible to generate that kind of temperature and to measure the volume at that temperature. So we extrapolate this. So it is found that this extrapolation, the extrapolation of this curve, it meets at minus 273.15 degrees Celsius, which is 0 Kelvin. Okay, which is 0 Kelvin. So this temperature minus 273.15 degrees Celsius or 0 Kelvin, this is absolute zero temperature. Okay, this is absolute zero temperature. Okay, minus 273.15 degrees Celsius. So here this gas which is under observation, it occupies 0 or no volume. Okay, and at temperature below, like I said, at temperature below minus 273.15 degrees Celsius, that is to go beyond that in the negative direction, it is impossible. And below that, the volume of the gas will be negative, which is a meaningless concept. Okay, which is a meaningless concept. At this point, the volume is 0. Okay, at this point, the volume is 0. If we go beyond this, okay, the temperature will be, if we decrease it continuously, we will go to negative volume, which is nothing. We cannot have negative volume, which is a meaningless concept. So this is the final point beyond which any measurement is not possible. Any measurement of volume is not possible. And also we will discuss it in kinetic theory of gases, that all molecular motion, it stops at this temperature of minus 273.15 degrees Celsius or 0 Kelvin. That's why this temperature is very significant, it is very important in thermodynamic discussions. This is called as absolute zero temperature. Okay, so this is the lowest temperature, minus 273.15 degrees Celsius, at which a gas is supposed to have zero volume. Again, I remind you that it is very difficult to make these observations. That's why the extrapolation concept is used. And at this temperature, the entire molecular motion stops, and that's why it is called as absolute zero of temperature. Okay, so this is the plot. Okay, and it is drawn using the concept of Charles' law, that is, volume is directly proportional to temperature. So we have taken the plot until 0 degrees Celsius, which is 273.15 Kelvin. Beyond that, in this, towards the left hand side, it is all extrapolation. So we have taken this, and it is supposed to meet at this point minus 273.15 degrees Celsius, which is equal to 0 Kelvin. At this point, all molecular motion stops, and beyond this we go towards negative volume, which is a meaningless concept. That's why it is the final point, which is called as the absolute zero temperature. Okay, and always remember this relationship, okay, between Kelvin and Celsius scale interconversion. Okay, so friends, I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.